Hello, class. Welcome to this second lecture on our Introduction to Statistics module. Here we're going to discuss some of the basics of research methods. As I mentioned before, it's impossible to talk about statistics unless we know a little bit of something about research methods. So I want to get a few things out of the way that are going to be useful for us throughout the rest of this course. And the more advanced we get into the statistics, the more we actually have to talk about research methods. The two go hand in hand with one another. But I've tried to set up a relatively brief primer right here so we can use the same kind of language when we're referring to specific research designs later on in this course. All right. So first of all, psychology is a science. All right, many people don't consider it a science, or they use the term something like soft science, but that is a lot of BS. It's a very, very difficult science. It's a lot harder than some of the other disciplines because a lot of our questions and answers are a whole lot more complicated than those of physics or chemistry. And one of the reasons why psychology is such a difficult discipline is a lot of the things that we're interested in are not directly observable. What we're interested in many instances in psychology are hypothetical constructs, constructs that we cannot directly measure. So how about your memory? How about whether or not someone has a mental illness? How much attention someone's paying to something? We can't directly measure those like we could how many milliliters of a solution there is. All right, how far did an object go when we throw it? We can take a ruler out and measure that, and everybody can agree that that is a good measure of distance. All right, for something like mental illness, it's not like we can stick a thermometer in somebody's head and accurately measure whether or not they have a mental illness or not. Okay, how much does someone love somebody else? Okay, there's no direct measure for this, and this is going to make psychology difficult. Right, even memory. If we're trying to study memory, we might get somebody to retrieve information, but as soon as they retrieve that information, it either strengthens the memory because they've retrieved it and they can study it at that point in time again. So it's difficult to measure things in psychology because we cannot directly observe them like we can in some of the other sciences. So do we give up hope? Do we throw our hands up in the air and say everything in psychology is unmeasurable? Some people have done that in the past, but that's not what psychologists do. To measure these hypothetical constructs, we come up with operational definitions of these constructs. All right, so what we do is for every hypothetical construct that we're interested in, we come up with some way to kind of try to measure it, even though it's not 100% the same thing as the hypothetical construct. All right, but it's something that's directly observable that way that if I were to measure it or you were to measure it and we could all look at that particular behavior, that particular brain activation, that particular amount of a particular hormone in somebody, that it would be replicable, that everybody would agree on this. All right, so if I were to ask you, we're doing a research study about how extroverted a person is. Well, I can't directly see that extroversion, but what I might do is say on a scale of 1 to 7, how much do you enjoy hanging around other people? All right, and based off of how they respond, this is our operational definition for how extroverted they are. Now, the two are not one and the same. The person could be lying to us, for instance. Okay, but it's something that's directly observable. Now, we could look at things like behavior. We could look at things like physiology. Let's say that we were trying to measure whether or not someone is paying attention. We might look and see how big their pupils get when they are looking at something. We can tell in psychology that how big your pupils end up dilating is an indirect measure of how much attention that they're paying to a certain stimulus that's on the screen. It's also a good way to look at attraction too, by the way. The bigger people's pupils are, the more attracted they are to a particular object or person. All right, so we need to come up with operational definitions for the hypothetical constructs that we're interested in psychology. Some of these operational definitions are going to be good measures of the hypothetical construct. Sometimes they're going to be bad measures. Here we have to evaluate our measures. We have to evaluate our test. We use a discipline known as psychometrics. We look at the reliability and the validity of our operational definitions to see if they do a good job of measuring the hypothetical constructs. Reliability, validity, terms that you've probably heard of before, but we'll talk a little bit more near the end of the class when we talk about correlation coefficients. All right, so for operational definitions, we need to do this both with our independent variables that we manipulate and the dependent variables that we measure for our experiments. So let's say, let's do the following research question that might be interesting for psychologists. Does owning a dog reduce anxiety? Okay, what do we need to operationally define here? Well, owning a dog is easily observable. You either own the dog or you don't. All right, but maybe we might want to operationally define, well, if you just got the dog for 1 month, maybe that's not long enough. Maybe you need to have the dog for at least 1 year. We might want to be specific about that for the purposes of our study. But for anxiety, we might want to come up with an operational definition for this. Are we going to use self-report anxiety? Are we going to have some indirect measure? Okay, maybe we see how many times the person plays with their hands throughout the middle of a day. Of course, some of these measures of anxiety are better than others. Maybe we look at brain activation and someone's amygdala, the center of the brain that processes things like fear and a lot of negative emotions. There's many ways that we could go about doing these. Some of these ways are better than others, but we need to come up with an operational definition because we can't directly observe anxiety in somebody. All right, does living in poverty lead to poor academic performance? We need to come up with a way to operationally define poverty. Okay, how much money do your parents make? Maybe we look at it that and we divide people into groups, or does your household make $30,000 and more, or $30,000 and less? Maybe that's how we divide our socioeconomic groups. All right, but we need to come up with a way to operationally define poverty versus not poverty. All right, we need to come up with a way of measuring academic performance. All right, again, not something that's directly observable. Maybe we look at their grades in a particular course of a child. Maybe it's the case that we have a standardized test. All right, but we need to come up with some operational definition to answer this research question. Does job burnout cause marital strife? Okay, how do we measure these things? Marital strife, do we put a video camera in your household and see how many arguments you get in with your significant other? Okay, that's a little bit invasive. Maybe there's some ethical issues there. Maybe it's self-report marital strife, but again, someone could be lying to us. Job burnout, all right? How can we tell whether or not someone's burned out with their job? Maybe, again, we use self-report. Maybe we use something like how often someone is off task at their job. How often are they checking Facebook or listening to, well, I don't want to say listening to music because you can do your job well while listening to music, but surfing the web for things that are not job related, right? How do we operationally define job burnout? All right, these are important questions for the psychologist and things that we have to be concerned with. Now, again, I want to note that for any hypothetical construct, for most of what we study in psychology, there is no perfect measurement of that hypothetical construct. Now, we can get at it maybe indirectly, maybe we have a good measure, but there is no perfect measure in all of psychology for any of these hypothetical constructs. And that just means that we need to take our test validation, looking at the reliability of our test. We need to look at those things and make sure that our operational definitions are at least doing a good job of measuring the hypothetical constructs that we're interested in. All right. So what are some things that we do in experimental research? All right, let's talk a little bit about some of the variables that we're interested in if we are conducting a scientific experiment. Again, this is something that you've probably encountered many times in your academic career. All right, independent variables, dependent variables, and confounding variables. The independent variable is the variable that the experimenter manipulates. All right, one group of people might have this particular level of the independent variable. All right, maybe they're put in the control condition and they are given a placebo drug. Maybe they're in the experimental condition and they are given a particular drug. Maybe it's something like antidepressant. All right, so the independent variable, this is what the experimenter manipulates. It's what they change depending on the group of the experiment. All right, ultimately what we're trying to tell is whether or not the independent variable in manipulating it has an impact on the dependent variable. All right, the dependent variable is the outcome measure that a researcher is interested in. All right, so maybe if we're trying to test out if a drug decreases depression, our independent variable is the experimental drug or placebo, and our dependent variable is the amount of depression. All right, and again, we might have to come up with an operational definition because we can't directly observe depression. Maybe it's something like a self-report. All right. So for experiments at least, we manipulate an independent variable and we see whether or not it has an outcome, an impact on our dependent variable. And while we're doing research, we need to be cautious of confounding variables. Confounding variables are any variable that the researcher does not manipulate and could possibly lead to the obfuscation or the confusion of the independent variable actually causing the dependent variable. It's any alternative reason why we might get differences in our dependent variables amongst our groups of our experiment. All right, so confounding variables, sometimes called extraneous variables, variables in the experiment that we do not manipulate, but might lead us to come to an alternative conclusion about the impact of our independent variable. All right, let me give you some examples of this. So let's say that we have a experiment and we're interested in what is the best way to teach statistics. And we have three different ways. We have way number one, in which we teach the class completely using the computer. We don't teach you any hand calculations. All right. Way number two, we teach you only hand calculations. And way three, we teach you both ways, okay? Both using the computer and hand calculations. All right. And then we see at the very end of a class, a semester-long class, whether or not that has an impact on a standardized statistics test. All right, so first of all, what is the independent variable? The independent variable is the teaching method that we use. All right, computer, hands-on, or a combination of both. The dependent measure is the standardized statistics test at the end of the semester. All right, so far so good. One thing that independent variables, since there are three groups, we say that there are three levels to that independent variable. All right, level is a term that we're going to be we want to be familiar with, especially early on. Okay, since there's three groups here, there are three levels to that independent variable. That's another way of saying it. These levels are going to be important when we talk about the analysis of variance. So let's say that we're interested in conducting this experiment, and we've got three statistics professors in the psychology department. We get Dr. Dawson to do the computer only. We get Chuck to do the hand calculations only. And then we get me to do the combination of both of them. And then at the very end of the semester, we take the standardized test and we see whose test grade is the best, or whose standardized test scores are the best. Now, is this a good experiment? And you might be thinking to yourself, no, this is a very bad idea for a research study. And one of the reasons is that there's a huge confound. All right. Each professor is only teaching one group. All right. Brian is only teaching the computer only group. Chuck is only teaching the hand calculation, and I'm teaching both. What happens if, let's say, that Chuck and Brian are the better statistics teachers? all right? Their scores might be higher just because it's them that taught the class, all right? My scores might be lower because maybe I'm not that good of a professor. Maybe I'm not that good of a teacher, all right? That might be a confound that might lead us to an incorrect conclusion about our research study. Perhaps the method of instruction has no effect whatsoever, but all of a sudden we come to the conclusion that as long as you don't do both, you're good. Okay, you either do computer only or you do hand calculations. So these confounding variables, sometimes called extraneous variables or nuisance variables, are a problem for experiments. And we need to make sure that we try to eliminate them as much as possible. We either eliminate them, okay, we might use a process of random assignment to try to get rid of them, more about which soon, or we at least try to measure these confounding variables, because if we can do that, we can statistically control for their influence on our dependent measure if we're good at statistics and if we've designed our study in the correct way. All right. In psychology, there are two major types of research. There is differential research. When you think of differential research, think about correlational research. Here, an experimenter doesn't, well, I don't want to say experimenter because that's the wrong term. A researcher doesn't manipulate any independent variable. They just measure a variety of dependent measures. And they look at the relationships between all of those dependent measures. All right. So for instance, we might be interested in a study about whether or not breastfeeding increases babies' intelligence. So we measure whether or not the mother breastfeeds the child, and then later on in life we measure their standardized intelligence score, and we see if there's a relationship between those. Now, the experimenter doesn't manipulate the variable. The experimenter doesn't say, hey, you breastfeed your kid and you don't. There's ethical problems with that. You can't do that. So we can look at the relationship between whether or not you breastfeed and the outcome of the child's intelligence. All right. The important thing with differential research is we can never prove causality. In this situation, we can't prove that breastfeeding your kid actually increases their intelligence, because there could be another explanation. Maybe it's the case that people that are more likely to breastfeed have more money because they are able to take time off of work to breastfeed, or they have a job that they're able to breastfeed. And this actually ends up explaining this relationship here with breastfeeding and children's intelligence. All right, it's really other things, not just breastfeeding, that leads to the increased intelligence. It's parental resources. So we're unable to prove causality, that one variable causes the other with differential or correlational research. But we can do that with experimental research. For experimental research, the experimentalist manipulates the independent variable to see if it has an impact on the dependent variable. This is the only way that we can prove causality in science. All right, so only when the researcher manipulates the independent variable are we truly able to prove that this change in this independent variable causes a difference in the dependent variable. So if we were to say, hey, you breastfeed your kids, and hey, you guys don't breastfeed your kids, then we would be able to conduct this experiment and truly be able to see whether or not breastfeeding improves baby intelligence. But as I mentioned before, it really doesn't. It has to do with other things like socioeconomic status. You have more money if you are able to breastfeed. But there's a relationship between those two things. All right. So if experimental research can prove causality, why would we ever want to conduct differential research? Well, sometimes we're unable to do experimental research because of ethical reasons. Maybe we're unable to do experimental research because we just don't have access to that data. Line of research that's important, how about the impact of childhood abuse on psychiatric disorders and mental health later on in life? This is a very important topic in psychology, but it's not like we can manipulate child abuse early on in life. That would be very unethical for us to do. So what do we have to do? We have to rely on the data that we are given. We have to look at differential research. So we are unable to truly prove causality in these situations. But we can still establish some important relationships here. All right, so what defines an experiment? Early on, when we're talking about research methods, I'm going to focus solely on the experimental approach. That's because the majority of classes that you take in the psychology major are going to be taught from the experimental point of view. Also, it's going to be a while before we get to differential research. Only until we get to correlational research or correlation coefficients and regression are we getting back to differential research in psychology. So we're going to focus, at least early on in our class, on experimental research. All right, what are 3 defining characteristics that a experiment has to have before it's a true experiment? Well, the first thing is manipulation of the independent variable. The researcher has to control the level, that is the word level again, of the independent variable that the subject receives. All right, the researcher determines, are you in group A, or are you in group B, or are you in group C? All right. Another thing that we try to do with experiments is try to remove as many confounding variables as possible. We try to eliminate these with a variety of techniques. We'll talk about those techniques here on the next slide, I believe. And the other thing is we try to make sure if there's any pre-existing differences amongst our groups, maybe it's, for instance, if we have some differences between the experimental group or the control group, we try to eliminate those before the experiment begins. Let's say that we're conducting a study on memory and our experimental group is better at memory than our control group, and we want to have some kind of manipulation to see if it changes. Well, they're already different at baseline. They're already different before the experiment begins. So we might come with an incorrect conclusion based off of these individual differences that already exist amongst our 2 groups of subjects. Okay, we need to try to remove any of those potential pre-existing confounding variables here. People might differ in the experimental control group on things like personality. They might differ on age. They might differ in gender composition. They might differ in intelligence. All these things might have an impact on your study. So, but we need to try to account for all of these differences amongst our groups before the experiment begins. All right. How do we end up doing that? Do we have to measure all of those different individual characteristics and make sure that we have equal numbers of men and women in both of our conditions, equal numbers of older and younger people in both of those conditions? That would be very onerous and would take a lot of time. All right, but there is a simple solution to try to get around this problem. All right, so I'm going to show you a couple of examples, and we'll talk about whether or not these are true experiments or whether or not these are not experiments. All right, so I am interested in the impact of sleep on your test score, your statistics test score. So the night before your first test in this class, either I don't come to your dorm room and you sleep sound and well, or I grab pots and pans and make an unholy racket outside of your dorm room so that you don't get any sleep. Okay? And the next day, we get a statistics test, and we see how you guys do on those statistics tests. Is this a true experiment? Well, I am manipulating the independent variable. All right? I've selected who is going to be in my control group and get all 8 hours of sleep, or however many hours a college student typically gets, and my experimental group, I'm waking them up. All right, I've manipulated that independent variable, and let's say I've tried to control for confounding variables. In this sense, we have a true experiment. All right, now let's look at another example here. In this, I'm interested in the effects of aging on memory, and I have young college students, and I compare them to older adults, maybe adults in their 70s, for instance, and I give them a memory task for items, and I see how well they do. Is this a true experiment? The answer is no. I did not manipulate age. I didn't say, you guys are in the old condition, you guys are in the young condition. All right, I can't do that. I don't have some anti-aging solution that can force these guys to be in their 20s, and I can't age these guys to their 80s. I have to look at the pre-existing conditions that already are there. All right, so this is not a true experiment. This is an example of what we might call a quasi-experimental design. This is a research study in which we have different groups, but those groups are many times they're pre-existing, okay? Or we didn't manipulate, or we're unable to manipulate who's going to be in those groups, all right? We're unable to use random assignment to randomly assign people to conditions. So another example of a quasi-experimental design, maybe I'm looking at the difference in athletic performance between members of the core and other UNG students. All right, if I were to do this study, I'm not manipulating who's in the core and who's not. I'm looking at people that are already in the core and people that are already not in the core. And there's other reasons why these people might differ that just doesn't have to do with the core, okay, whether or not you're a member of the core. Maybe there are personality differences between individuals that decide to join the core versus individuals that don't. If I'm looking at differences between older adults and younger adults, sure, age is different between these individuals, but also the generation that they grew up in. All right, I don't see any weird items here, but maybe let's say I had something like a cell phone. Maybe that's something that older adults are unable to recognize, and they might have more trouble remembering that cell phone object, okay, compared to young adults. So I might get a difference in memory items that has nothing to do with age and completely has to do with the generation that you grew up in. I could present you a list of famous faces from the 1950s or 1940s. The older adults would do much better on a memory test of that compared to young adults, all right? So we might get differences that are due to the generation, not necessarily due to age. So we're unable to prove causality with a quasi-experimental design. Another good example of this is studies that we look at the difference between men and women. All right, I can't randomly assign you to be a woman or a man on a particular day to complete our experiment. And since I can't randomly assign you to be in this condition or this condition, this level of the independent variable or this other level of the independent variable, it's not a true experiment. Okay, can't prove causality. Another example of this is a pre-post test design study. So let's say that we're interested in, let's just say something like brain training, all right? We measure beforehand how good your attention is, and then we do some special intervention. Maybe we get you to do Lumosity, maybe we get you to do some brain training game, and then we test afterwards to see whether or not you did better, all right? So this is the research design, pre-post test design. I'm unable to randomly assign you to be in the post-test condition first and then the pre-test condition. So maybe you improve from pre-test to post-test, not because of the intervention, but just because you've done the task twice. All right? The second time you have the attention task, you're probably going to do better on it. All right, so this is a potential confounding variable that takes place because we're unable to randomly assign you to be in the post-test condition first, for instance. A good example of this, some research by Hans Eysenck, okay, a famous individual in the history of psychology, studied a lot about personality, but he had a very influential paper that came out in 1952 in which there were a lot of psychotherapists, and at the time they were, the majority of them were Freudian, or came from the psychoanalytic tradition, and they were looking at their patients, and they were saying, hey, look at how well our patients are doing after they see us in the psychiatric hospital. They are leading really good lives, and they're no longer having these problems. Well, Hans Eysenck pointed out that, well, even if you did nothing, even if they didn't seek out therapy, in many situations, they would do better, or they would get better, just via time. So there's a potential confounding variable there. All right, Hans Eysenck wasn't making the point that therapy was useless. He was just saying that to truly evaluate the claims that this therapy is useful, you would have to do another kind of research design. So here we have our control group that does pre-test and no intervention, and then they have the post-test. And then we have people that might undergo psychotherapy, pre-test, intervention, post-test. And if we see maybe some result that looks like this, where maybe the program increased happiness relative to the comparison, maybe we can say that psychotherapy is useful in this situation. So quasi-experimental designs, designs in which we are unable to manipulate the independent variable, but we still have different levels of the independent variable. So pre-test, post-test, male versus female. All right. How do we control for these confounding variables? What do we do to remove these? Well, the easiest thing that we can do is try to eliminate these confounding variables. Let me give you a good example of this. The first research study that I did at UNG took place over the summer, and it took place in room 104, which is the room that we have our class in. And while we were running our first subject, we didn't realize it, but we had scheduled them the same time that a class of Mandarin Chinese was going on in the room opposite of our running room. So they were blasting I believe it's Nickelodeon or Nick Jr. show, Ni Hao Kailan, at full volume. Also, I believe that there was some Chinese pop music that was being blasted pretty loud as well. Huge confound. I do a lot of my research on attention and memory. And if you're trying to pay attention to something and they're blasting Mandarin Chinese in the room next to you, you're not going to do that well on the test. All right. So what can you do to eliminate this confound? Well, you have noise canceling headphones. You tell the class next door to be quiet. Of course, we can't do that, unfortunately, but you go to a situation that there isn't that external noise. All right. There isn't the flickering of lights. You make sure that everything is consistent. All right, so try to eliminate any confounding variables that you might have. If there is a confounding variable, you make sure that all the groups have equal levels of that confounding variable. So for instance, the time of day might impact someone's performance on a test. College students typically do better in the afternoon than they do in the morning for tests. So if I had all of my experimental subjects take the test in the morning, and all of my control condition subjects take the test in the afternoon, I might get differences that have nothing to do with my independent variable. So I want to make sure that the time of day that they take the test is pretty much the same. I'm going to keep that confounding variable, the level of that confounding variable, equivalent across all my different conditions. I had a friend, a colleague that ran a study that ran into some problems because what she decided to do was to run everybody in the experimental condition first, early on in the semester, and then run everybody in the control condition later on in the semester. Now, you might have participated in research studies here at UNG. If you participate in research studies early, typically your data is pretty good. Typically, you're going to get the students that are not procrastinators, that they are on the ball. Their data is going to look good. If you wait to the end of the semester, where people need the course credit to graduate, or they need the course credit to do well in the do well for the class, well, your data might not look that good, and so you might get differences just by the timing in the semester. So any of these potential confounding variables, we want to make sure that if we can't eliminate them, we're going to try to set them equal across all of the different levels of our independent variable. Another thing that we try to do here is standardizing any of the research protocol. So one thing that I do in my research is, instead of giving instructions to participants via mouth, via me just talking to them, I might say the instructions differently depending on who I'm talking to. Maybe I might say the instructions slower to one person and quicker to another person. Maybe some person I'm already done with, and I don't give them the instructions well at all. Now that would be problematic. So one thing that you can do is maybe write a research script and say word for word exactly what's on that piece of paper. So people receive the exact same instructions. Another thing that you can do, and something that I enjoy doing, is get the computer to explain the instructions to them. The computer is going to give it the exact same way every single time. So we're going to standardize our research protocol so that everything is consistent for every single subject that participates in our experiment. All right. But by far, the golden way of dealing with confounding variables, especially any individual differences that might exist naturally amongst all of our subjects, is by using random assignment. Random assignment is where people are randomly put into either this condition or that condition. All right, people have an equal likelihood of being placed in any of the levels of our independent variable. All right, so if you come up to my experiment, I flip a coin, and if it's heads, you're in the experimental group, and if it's tails, you're in the control condition, at least for a two-level simple experimental design. All right, this way it ensures that if there are any individual differences that might impact my research study, any potential confounding variables, like maybe having more guys in one condition than the other condition, maybe having older subjects in one condition compared to the other. If everybody has an equal likelihood of being in each condition, over time with enough subjects, those individual differences are going to average out between our experimental and our control condition. All right, with enough subjects in each of them, those potential confounding variables may be due to personality, may be due to intelligence. My experimental and my control conditions are all going to have equivalent levels of those individual differences. So random assignment is very, very important. Random assignment, I want to mention, is different than random selection that we talked about last time. Random selection has to do with obtaining a sample that is representative of a population. Random assignment has to do with assigning people to levels of an independent variable to ensure that any pre-existing individual differences are equivalent between all levels of the independent variable. All right. The idea behind random assignment is that all conditions start with the similar amount of whatever confounding variable might be at play, things that we might not have even thought about. Okay. Thus, we are sure that our manipulation of our independent variable causes any changes that we see in our dependent variable. And if we have a confounding variable and there's nothing that we can do about it, we can't eliminate it, we can't keep it at equal levels, standardization won't get rid of it, random assignment won't get rid of it, measure it. All right, if we measure it, sometimes there's a statistical way to remove the influence of that confounding variable. Sometimes, not in all situations, but the more fancy statistics that you have, the more likely you are to deal with these pesky confounding variable problems. All right. Now we get to a part in our discussion that's going to give people grief. And I know it's going to give you grief because I've taught this class a few times, and this is something that is very, very important, and we're going to talk about it from now to the end of the class. There are two ways of manipulating an independent variable. We could use a between groups manipulation, or we could use a within groups manipulation. And depending on which manipulation we use is going to dictate the statistic that we're going to use. If we have a between groups manipulation, we're going to use one category of statistics. If we have a within subject manipulation, we're going to use another category of statistics. So it's very important that we're able to identify what kind of manipulation we're looking at and what kind of manipulation we want to do. All right, let's talk about between groups manipulation first. Okay, with a between groups manipulation, subjects are put into either this group or that group. Subjects are only in a single group. Okay. Every subject receives only one level of the experimental manipulation. Let me give you an example here. So let's say that we're looking at whether or not your test scores are impacted by loud noise in the testing room. we're going to take our subjects, we're going to flip our coin, and if it's heads, they're going to be in the experimental condition where we've got this loud band playing. And if it's tails, they're going to be in the control condition. They take their test and we get one score for every single subject. That is the between groups manipulation. It's between groups because you're either in group A or group B, and we're looking at the difference between the two groups. Sometimes this is called an independent groups manipulation or an independent groups design. All right. Most of the time when we talk about experimental versus control groups, we're talking about a between groups manipulation. But again, remember, you're in either this group or you're that group. All right. You're not in both groups. You only receive one level of the experimental manipulation. We can contrast this with a within subjects design or within subjects manipulation. Sometimes this is called a repeated measures manipulation or repeated measures design. In this situation, subjects receive all levels of the experimental manipulation. So again, if we were to look at this study, maybe you come into the study and you first take the test in a quiet room, and then after you're done, you have to take another test and you take it in a room with the loud band. All right. And here we're looking for differences, but we're not looking at differences between subjects in group A and subjects in group B. We're looking at differences within people, differences between or when you were in the control condition and your score there, and in the experimental condition. Every subject in this situation is giving us multiple data points. They're giving us a test score in the control group. They're giving us a test score in the experimental group. We're getting more data per subject with a within subjects manipulation. Everybody is both in the experimental condition and the control condition. All right. If we do a pre-test, post-test design, all right, we have you before psychotherapy and after psychotherapy. All right, this is a within subjects manipulation because we are looking at you both before psychotherapy and after psychotherapy, and we're getting two data points: your depression or anxiety before psychotherapy and your depression or anxiety after psychotherapy. You're in both the control condition and the experimental condition. All right. For our first recitation, we're going to have some problems that I want you to identify. What is a between groups manipulation and what is a within groups manipulation? So be mindful of that. All right. So let's look a little bit more in depth at a within subjects manipulation. We could do it where you get the control condition first, and then you have the experimental condition. But there's a potential confounding variable here. If you have the experimental condition second, maybe it's the case that you learned something about that test. You learned how to do that test better. So maybe people do better the second time around just because of practice. Maybe it's the case that they get tired the second time they do this test. And because of fatigue, they do worse. In these situations, we would come to an inaccurate conclusion that our experimental manipulation had an impact on our dependent variable, when in fact, it was the ordering of receiving the conditions that had an impact on the dependent variable. So these kind of confounding variables are called order effects, and these are confounds due to the presentation order of the experimental and the control conditions. All right, maybe we get practice effects. People get better the second time they do a task. This happens very frequently. What happens less frequently, but still might happen, fatigue effects. People might get worse at a task if they have to perform it a second time. All right, because of these confounding variables, order effects, we have some research design way of controlling for these order effects, and that is known as counterbalancing. For counterbalancing, what we do is different subjects receive different orderings of the control and the experimental condition. So if we were to counterbalance the research study that I just talked about, half the subjects would have the control condition first where the band wasn't there, and then they would have the experimental condition where the band was there. And the other half would have the experimental condition first, and then the control condition. And because half of them had this order and the other half had this order, if there were any practice effects, the practice effects are going to affect the second condition. Well, it's going to affect the experimental condition and the control condition equally, because equal numbers of people have this order and this order. All right, so counterbalancing is a useful way of dealing with order effects when we have a within subjects design or have a within subjects manipulation. So you might be asking yourself, well, there's two different kinds of manipulations. Is one better? Shouldn't we just always use one of them? Maybe we always use the between groups design. Maybe we always use the within subjects design. By the way, I've just noticed here, between groups, between subjects means the same thing. If I talk about within subjects or within groups, I'm talking about the same thing. So as long as I say between, we're talking about between groups manipulation. I say within subjects manipulation. Okay, which of these is better? As with most things in psychology, the correct answer is it depends. Okay, there are advantages and disadvantages of both within subjects and between subjects design. One advantage that you get with between subjects design is there are no order effects. All right, you don't have to worry about practice effects or fatigue effects. People only give you a singular data point. Another advantage is that there's some research that you could only look at by doing a between subjects or between groups manipulation. If you have a surprise memory test at the end, or let's say that we have a social psychology experiment and we lie to you, like the Milgram studies, okay, we can't get you to, after we say, ha, we got you, this study was all about obedience, okay, we can't get you to do it again, all right, the jig is up, you know what the study is about. All right, so there's some research questions that cannot be answered with a within subjects design or with a within subjects manipulation. So especially studies that require deception. All right, with these studies, we cannot deceive a subject twice. All right, so we have to use the between groups manipulation. How about within subjects? Why is this a advantageous way of conducting research? And I'd say when I conduct experiments, I am all about the within subject's life. This is the way that I typically go. The reason for that, first of all, subjects act as their own control. Remember all those pre-existing conditions? Maybe it's the case that our experimental group has older people in it than our control condition. Maybe it's the case that people in our control condition are more agreeable than individuals in our experimental condition. You don't have to worry about that with the within subjects manipulation because every subject is their own control. You're comparing people to themselves. You don't have to worry about any of these pre-existing individual differences that might be different between your experimental and your control condition. Another advantage, and this is the advantage that I like the most, is you need fewer subjects when you have a within subjects design. All right, you roughly need half the subjects for within subjects design as you would a between subjects design or between groups design. For the within subjects design, you're getting twice as many data points, at least twice as many data points per subject. So you gain more data per subject. You're comparing people to themselves. You need fewer subjects. So this is a really big advantage of within subjects designs. All right, decent amount of information. And again, when you have research methods, you're going to go into all of this in a lot more detail. But we'll end this video right now, and we'll talk about different types of variables in the next video. Thank you guys, and have a great day. Bye-bye.